Okay, so now we're on the 2022 TYS question 1. Now in question 1, I think it's quite difficult for most students who have never seen this before. However, stay calm and think through. Firstly, you are told these are elements from the first 2 periods. Period 1, period 2. So now you look at the diagram, then you work out. Each element has dots and crosses, right? That represents their electrons. So how many crosses are there? T has 6 crosses, meaning 6 valence electrons. 6 valence electrons is group 6. Given that this is first 2 periods, period 1, period 2, this must be oxygen. So T is oxygen. R. If you do the same analysis, the dots are R. 4 valence electrons. Carbon. Next, Z. Z only has 1 electron. Hydrogen. Z only has 1 electron, right? Can't be lithium, can't be group 1 because it's covalent bonding. Lithium doesn't form covalent bonds. It's a metal. Metals don't form covalent bonds. Finally, Q. Q has 7 crosses, meaning group 7. Meaning fluorine. So once you have worked out the identities of the 4 elements, okay, still got one more, sorry, M. M has 5 crosses, meaning M is group 5. Nitrogen. Did I miss out anyone? No. Okay. So these are the 5 elements, right? Once you have worked out the 5 elements, the rest is ultra simple. Many students got B wrong because, again, carelessness. Oh, it's not carelessness. It's just close reading. Proton number 6. This is carbon. Some students went straight away to think, oh, proton number 6. Okay lah, the 6 electron one lah. Oxygen. No. Oxygen has 6 valence electrons. But oxygen has 8 electrons in total. It has 8 protons. So the one with 6 protons is carbon. So please read carefully. I cannot stress this enough. Don't rush. 1 mark, 1 minute. You have 1 minute to go and find the proton number. Carefully, properly. All right. Next, part E. Which 2 elements exist as diatomic? Then everyone is like, wow, so easy. Oxygen and fluorine. O2, F2 ma. Hello? Did we read this second part? It must contain single bonds. O2 has a double bond between oxygen. Therefore, that's not the answer. The answer they want is just Z and Q, which is hydrogen and fluorine. So this one, also many students got it wrong. Finally, the last one. What's the formula of the molecule with a molecular mass of 88? So you have to go and calculate the MRs. If you calculated the MR, you will get the RQ4. Now, please use the symbols M, Q, R, T, and Z. You are told. Don't go and be smart and write CF4. Don't do that. You are already told to use the letters M to Z. So don't change it. Okay? Now, moving forward from question 1, let's go to question 2. Now, question 2 is not difficult. However, you need to know what is the concept or chapter that is tested. Most students did not realize that this was about kinetic particle theory. And most students didn't realize it was about diffusion. As a result of that, most students' answers did not have diffusion inside them. If you look at my answers, they have diffusion inside them. You must use the word diffuse. So the perfume molecules diffuse from a region of higher concentration to a region of lower concentration down a concentration gradient, meaning from higher to lower. Okay? Next, part B. Describe what changes in the diagrams are necessary to show what happens when a liquid is added to another liquid. All right. So again, most students were lost because they didn't make the connection with KPT. It's about KPT. So of course, in the liquid, the particles are packed more closely together. That's number one. Number two, a lot of students immediately thought, oh, diagram means the circle, circle, circle only. No, the diagram includes the words below it, right? So the time taken for it to diffuse and spread out would be longer. Definitely won't be a few seconds if it was a liquid, because diffusion will be slower in a liquid compared to a gas. Finally, you got to ask yourself, not all liquids are miscible. Gases are miscible, but liquids are not. Not all liquids are miscible. For example, if it's water and oil, they are immiscible. Therefore, the diagram, if it's immiscible, will not be homogeneous mixing, meaning the particles won't be evenly homogeneously spread out, but rather the denser liquid's particles will sink to the bottom. All right, so these are all the possible answers you could have given. And in fact, this kind of question you must score because they don't require you to have specific keywords that cannot be paraphrased. They just want to see your thinking. Are you able to think? All right. So that's part B of 2022. So far it's about KPT and diffusion. You must identify the topic and the concept diffusion properly. And moving on, part C. Many students were tricked by the question because it's written rate of movement. So many students just use the word move, but that's incorrect. Again, how does it move? What process causes it to move? The process is obviously diffusion again. Hence, you must use diffusion in your answer. So obviously, this is about rate of diffusion. Rate of diffusion changes depending on temperature, depending on AR. Why I use the word AR, not MR? You gotta think. Hey, this is just vanadium. It's not vanadium oxide, vanadium nitrate. That one will be a formula mass, right? There's more than vanadium inside it. This is just vanadium on its own, right? Sure, it's a charged ion, it's part of a compound. But here, I'm just looking at vanadium ion on its own. That is again AR. So the answer is simply about rate of diffusion, temperature, rate of diffusion, AR. That's it. Okay? So if you look at my answer, it's very, very specific. At a higher temperature of 30 degrees Celsius in B, the rate of dissolving and the rate of diffusion will be faster. Now, rate of dissolving, you learned it in Sec 1. They can test Sec 1 stuff as well in the Pure Chem exam. So you have learned, right? As temperature increases, the rate of dissolving also increases, as well as the solubility. All right. So you need to know this. The rate of dissolving followed by the rate of diffusion is also faster. Therefore, the ions will diffuse faster and further. Many of you always leave out the further, the distance. The distance move is further, longer. All right. So same here for C. The distance move in C will be longer because vanadium has a smaller AR of 51 compared to copper, which is 64. Therefore, vanadium ions have faster rate of diffusion and will diffuse faster and further. Please ensure your answer looks like this. It needs to have rate of diffusion in the answer. Don't be tricked by the question and just use the word move. Obviously, they can't tell you it's diffusion because that would be giving the answer away. All right. So the examiner's remark for 2022 actually stated that many students didn't even refer to diffusion in their answer. To be honest, I think for those who didn't refer to diffusion in your answer, I gave you 2 out of 4. My suspicion is at O levels, they might have given 0 out of 4. Because the moment your concept, your key concept, which is rate of diffusion, is not there, they will actually minus away all the marks. Okay, so just take note. You must get the key concept there. The key concept is just read the question, think about the chapter, think about the topic, think about the key concept. Okay, so the key concept here is diffusion. Okay, moving on, A3. Now, A3 is about organic chem. And I think it starts out quite easily. Okay, most of you would have gotten these correct. All right, B is a carboxylic acid, it has COOH. C is an alkene because it's a carbon-carbon double bond. That's a functional group of alkenes. Finally, alcohols has the hydroxyl OH functional group. However, for part B, I think most of you, even though I marked you correct, would probably not have written this. Most of you probably said add aqueous bromine to C, which I marked it correct, not because I didn't spot the error, but because you don't know the boiling point of C. If you look at C, C is propene. It's a 3-carbon alkene propene. From ethene to butene, they are all gases. Basically, for alkanes and alkenes, the first 4, from the first carbon, 1 carbon to 4 carbon, alkane and alkenes will be gases, meaning propene is a gas. If propene is a gas, you cannot add aqueous bromine to it. You must bubble it into aqueous bromine. A gas must be bubbled, okay? So the aqueous bromine is then decolorized from reddish brown to colorless. Okay, I think many of you still somehow like to write brown. It's incorrect. It's reddish brown to colorless. Okay? Can? So just take note, propene is a gas, so you must bubble it into aqueous bromine. Next. The next part, I think most of you could do most of it. I think most of you just left out in part 2. Why does it turn universal indicator orange? Hello? They don't just want you to say there's a carboxylic acid. If they want you to say there's a carboxylic acid only, then they wouldn't say orange. Orange means it's a weak acid. And the pH is 3 to 4. All right, so this was also the examiner's comment. Many students didn't mention that carboxylic acids are weak acids. So again, specific answers. Think, why am I telling you it's orange? I'm telling you it's orange because I want you to say that it's a carboxylic acid and it's a weak acid and the pH is about 3 to 4, hence orange. All right. So up to this stage, you can see a few tricks are planted in a very simple question to actually see whether students pay attention to the words in a question. Okay. I think finally, the empirical formula is not difficult. I think most of you can deduce is CH2O. Okay. The explanation, which compound has the chemical empirical formula CH2O? This one I think is probably easiest to explain like this. The molecular formula of B is C2H4O2. Just add everything up. It's got 2 carbon, 4 hydrogen, 2 oxygen. So 2, 4, 2, right? So in the simplest ratio, it'll be 1, 2, 1, which fits the empirical formula, right? 1 carbon, 2 hydrogen, 1 oxygen. So this is probably the simplest way to explain it. Okay, now I'm just going to go very quickly on to question 4. Again, we will not go through every part. Okay, the answers are found in OneNote. If you have any questions, you can go and refer to it later on your own. But importantly, I want to go through the parts that many of you seem to have had problems with. Okay. Now, question 4, the first part, was meant to be easy. It was meant to be easy. However, the candidates in 2022 didn't know the colors or the states. Color and state means what? You need to get the state, gas, liquid, solid correct. You must get the color correct. So just look at it, guys. Many of you didn't write greenish yellow or yellowish green for chlorine. Many of you didn't write reddish brown for bromine. You wanted to write brown. That's wrong. Many of you didn't write purple black. Some of you thought that iodine was brown. It's not. Iodine is a brown solution, but as a solid, it's black. So this is what you must memorize. They are not the same things. Dissolved in water as a solution, iodine is brown. True. But here they're asking you for the element. The solid element iodine is purple black. So these are the colors and the states of the group 7 elements that you must memorize. And you do so by revising periodic table. Next, I think the next one is not difficult. Most of you were able to deduce anyway. Most of you memorized that the reactivity of group 7 elements decreases down the group. And then you just use displacement to explain it. For example, chlorine, which is above bromine and iodine, can displace both bromine and iodine from their compounds. This one not difficult, but can I just draw your attention? You displace bromine, iodine, chlorine, displace bromine, iodine. The element displaces the element. I don't want to read things like bromide displaces iodine. That's wrong. The element's name is bromine. Bromide is the ion. So it's the element displaces element. Just like how magnesium displaces copper from its compound. So same here. Chlorine displaces bromine and iodine from their compounds. Now, this question was not well done, shockingly. So the examiners were very surprised that how come the students don't know how to explain this? And what did they mark for? They marked for this one. Chlorine displaces bromine and iodine. The moment you use the wrong word, wrong, no, zero, no, the examiners gave. So you must be very, very mindful. All right? Just check your work. Make sure it's written correctly. Make sure it's work that you're proud of handing in. Check for grammar. Check for wording. All right? There's enough time to do that. This paper, I can finish the section A in 40 minutes. So for you, I think you can finish it in 50 minutes easily. Okay, next, I think part 2, most of you also know. Okay, bromine displaces iodine, right? So that's why you form a brown solution of aqueous iodine. Okay, and so on and so forth. I think B and C is not a problem. D also not a problem. I think most of you knew that. All right. Why is it that chlorine atoms can act as a catalyst? So importantly, chlorine atoms are used up in the first step, regenerated in the second step. Regenerated is the word. Yes, you can use other words to paraphrase, but make sure the paraphrased words mean the same thing. Regenerated is the best word. And finally, please say that they are chemically unchanged at the end. If you didn't write at the end, please write it in now. Okay? So this is how you identify the catalyst. You identify the catalyst from the equations based on, number 1, used up, number 2, regenerated in a second step or third step. Okay? Now this one tells you that it's chemically unchanged at the end of the reaction. This is where you must absolutely study my enrichment. This is inside the enrichment. Now this is under homogeneous catalysis. You have learned 2 types of catalysts. Homogeneous, which is where it's the same state as the reactants. Heterogeneous, where it's a different state. Okay, please read the enrichment. The enrichment gives you the context, the problem-solving skills needed to deal with the very difficult questions that can come out. Okay, so if you want to spend time reading, read the enrichment for every chapter. Okay, D part 2, explain why CFCs are harmful. I think most of you know. CFCs, chlorofluorocarbons, all right? They deplete the ozone layer, they destroy ozone, they form oxygen. As a result of that, the ozone layer is depleted, and as a result, more harmful UV rays from the sunlight reaches the surface of the earth and causes skin cancer. Okay, this one I think most of you know. Okay. Okay, moving on to question 5. Now, question 5 is not difficult. I think most of you know fuel cell. Now, a fuel cell's overall equation. is the same as the combustion of hydrogen. Now, this is really, really crucial. All right. The fuel cell's overall equation should be the same as the combustion of hydrogen. Now, even if the question didn't say that, you need to know that. You are expected to know that a fuel cell uses the same overall reaction as combustion, meaning the overall reaction just is combustion. This plus O2 gives you that. That's it. All right, it's always like that. It need not be hydrogen. It could have even have been other things. It could have been, let's say, ethanol. There are some fuel cells which make use of ethanol as the fuel. So you need to know it's always combustion, combustion, combustion. All right, in a fuel cell. But is the ethanol or the hydrogen really burning? Do you see fire, heat in a fuel cell? The answer, of course, is no. You do not see fire. You don't have heat energy from a fuel cell. The main reason why you don't have that reaction, that heat, is because it's not really burning. We must ensure that hydrogen and oxygen are kept separate. Now, why is it so important to keep hydrogen and oxygen kept separately at different ends of the fuel cell? Why is this even important, right? So now I want you to write down the reasons. Number one, the most important reason is to ensure that the electrons flow through the external circuit from the negative electrode to the positive electrode. If hydrogen and oxygen were allowed to mix, all right, then they will just react together. There won't be electron flow through the circuit anymore. There will just be electron flow from one chemical to another chemical. Full stop. All right. The whole purpose of a fuel cell is to generate electricity to power a car, a machine, right? So it must flow through the circuit where the machine, the cars are. The second reason, of course, is this. Hydrogen reacts explosively with oxygen. So if there's a leakage and the two were somehow allowed to mix, the fuel cell and the car, the machine, will explode. So these are the two reasons why hydrogen is always kept separately from oxygen in a fuel cell. They are kept as separate ends. They never ever mix. And that's why it's not a simple combustion reaction, even though the overall reaction is indeed a combustion. Next, you must be able to write the equations, the half equations for the electrodes in a fuel cell. First, the negative electrode is where the hydrogen will be. All right. So the hydrogen reacts this way. So the hydrogen reacts this way. The question now is this the anode or is this the cathode? So you got to think, after writing the half equations, is this a loss or is this a gain of electrons? It's quite clear-cut. The electrons are lost because the electrons appear on the RHS. So if it's a loss of electrons, is it oxidation or reduction? If it's a loss of electrons, it will be oxidation. Therefore, this is the anode. The positive electrode is where oxygen is. oxygen, Vx this way. And this is, of course, the cathode. Because it's a gain of electrons, it's reduction. And what do you notice? How do you better memorize this? Do you realize this is the reverse of electrolysis? This is the reverse of electrolysis, which is what I said during the lesson when I went through fuel cell. That's how you memorize. Electrolysis is 4OH minus becomes O2 plus 2H2O, right? This is the reverse of it. O2 plus 2H2O becomes 4OH minus. Okay, now you must copy this down. Imagine if this year your 4-mark, 5-mark is describe how a hydrogen fuel cell works using half equations and explain the benefits of a hydrogen fuel cell to the environment. Imagine if this was the essay this year. You need the equations. You need to know why hydrogen and oxygen are kept separately. You need to know, finally, how is this beneficial for the environment? Okay, Ken. So let's take this down quickly. Okay, moving on. Now, the next question is not difficult. Most of you knew that it was 250 cm³ of oxygen. However, the question is not about oxygen. The question wants you to calculate the minimum volume of air. Air is not all oxygen. Only 21% of air is oxygen. Therefore, if you need 250 cm³ of oxygen, how many cm³ of air will that be? We take 250 divided by 21 times 100. That will give you the total volume of air that you need, which is 1190 cm³ to 3SF. All right. Next, this is also why it's important to write statements. If you don't have statements, we don't know where is your answer. All right. So please ensure you write statements like volume of air equals something, something. So please don't be tricked. Read carefully. Don't just assume they're asking you for volume of oxygen. Here, they're asking for volume of air. Next, I hope none of us went to convert to number of moles. There is no need to, because hydrogen is a gas, oxygen is a gas. Just compare their mole ratios as volume ratios. Okay? Now, part C. Suggest one reason why KOH is used in the fuel cell instead of pure water. So, one important trick in chemistry is always like that. When you see words like this, why A is used rather than B? Think, what's the difference between A and B? What's the difference between potassium hydroxide and water? Potassium hydroxide is giant ionic, right? Water is simple molecular. So clearly, aqueous potassium hydroxide has a greater electrical conductivity because it has free-moving K plus OH minus ions to conduct electricity. So always ask yourself, what's the difference? What's the difference between A and B? That will give you the answer every single time. Every single time the question is worded like that, just ask yourself, what's the difference between A and B? Between potassium hydroxide and water. And once you have grasped the difference, you will be able to get the answer very, very quickly. Okay, so that's A, B, and C for the fuel cell. For D, I think most of you can do this, so I shall leave this for you to check on your own. Now let's go to question 6 now. I think many of you, when you got to question 6, you were a bit lost because you didn't know how to make dilute ammonium sulfate concentrated. And you didn't know how to get the 2 marks. The 2 marks are just what? Just heat the dilute ammonium sulfate in an evaporating dish. But you don't heat until saturated. That's not the point. You're not getting crystals here, hello. You are just evaporating the water away. Don't heat all the water away. Just evaporate most of the water away. Don't proceed to filter, crystallize, don't want. I still want aqueous. Why are we crystallizing? Read the question. Answer the question. If you want aqueous, don't crystallize. Just evaporate most of the water and leave it be. All right, and that's it. All right. So no other methods will work. no other methods will work. So you will not use distillation, you will not use filtration, you will not use fractional distillation, nothing else, only this. All right? Can? And that's it. That's all you need to write for 2 marks. Okay, so how do you actually get the 2 marks? They just wanted you to write heat in evaporating dish, 1 mark. Evaporate most of the water away, 1 more mark. That's it. Now, the next few are quite straightforward. I think the equation is difficult to write. Okay, so please be careful. Interpret the diagram correctly. So process 2, right? You must add in oxygen. So add in oxygen. Then what do you form? Very important. You form sulfur dioxide and water and nitrogen. So in blue are the products, in yellow is the reactant, ammonium sulfate as well as oxygen. All right. Next, the oxidation state is the one that's difficult. I think most of you are so used to positive oxidation states that you have actually forgotten there are actually 2 good examples when nitrogen is negative. Hydrogen is +1. As a result of that, nitrogen is -3. So ammonia and ammonium ions are where nitrogen has an oxidation state of -3. All right. Next, the uses of sulfuric acid. You must know this. You must memorize it. So the 2 best examples are, number 1, manufacture of detergents. Number 2 is used as an acid in car batteries. So car batteries use sulfuric acid as the acid. Okay. Now, let's go to part D. Now, part D is the one that most of you probably don't really know where you went wrong. If you look at my answer, right, actually, I didn't really go beyond the line. Okay, it's possible to get 3 marks just by writing this. So first, these are the green chemistry principles. These include blah, 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 right? So process 1 follows the second principle. Process 2 doesn't follow the first principle, and so on and so on. So you just need to read and figure out. Process 1 follows the second principle because it reuses a waste material, ammonium sulfate, from the manufacture of other chemicals. Then you read, oh, process 2 needs 1000 degrees Celsius, so it needs a lot of energy. So it doesn't follow the first principle. However, most of you probably got this one wrong. It follows the third principle. The waste product is not SO2. SO2 is the desired product. The waste is not SO2. The waste product is N2 and H2O. All right. So most of you were so quick to say, well, acid rain lah, don't know what lah. Think, is SO2 a waste product? It's not. It's what you want to make. So that's what makes 2022 tricky. It seems so easy, right? It's about acid rain. It's not about acid rain. You need to know that sulfur dioxide is a desired product, not a waste. So the only waste products here are water and nitrogen. All right. Now, later after this lesson, I will send you all a document, all right, on green chemistry. If you have time, you can read it. So previously, when I was teaching in a different school, okay, let's just leave it as that, I used to have advanced modules. So I write advanced modules. One of the advanced modules I've written was for green chemistry. All right, so there are 12 green chemistry principles. So if you have time, you can read it so that at least you are familiar with what green chemistry is. Okay. Now, moving on to the database. Okay, we have gone through this actually in class before when we were doing polymerization. Now, this is all about polyethylene, and I'm sure you know that polyethylene is a polymer. It's made from ethene monomers, and the reaction is addition polymerization. So this first reaction in 7.1 is not difficult. You know this. However, English, however means now I talk about contrast, something different, right? So now you must pay attention, captures your attention. So words like however should capture your attention. So however, this is a simplified structure. Yes, it's simplified. All right. In industry, different processes are used to manufacture different types of polyethylene, each with a different structure. All right. So the three structures are here. Immediately, oh my God, you should just highlight like that, right? What am I highlighting? I'm highlighting branched, very branched, not branched. Very branched with many side chains. Not branch means no side chains. So this is what you annotate in an exam. When you're faced with something new like data, like a structure, like a definition, annotate like this. The moment you have annotated this somewhere, answering the questions that follow will be much simpler. All right. So you can see that LDPE, low density polyethylene, is very branched, many side chains. And the side chains can be 1 carbon, 2 carbon, 3 carbon, 4 carbon, and so on. Whereas LLDPE has side chains, but fewer. And the side chains are all methyl groups, CH3, CH3. Finally, HDPE is completely not branched. It's no side chains. Then you continue reading. Oh, wow. So the side chains again is the same thing, right? What I highlighted just now in blue was just like all these are side chain, side chain, side chain, right? Now the carbon atom chains that branch out are known as side chains. See, if you listen in class, we have gone through this before. We have talked about side chains before. All right, so now polymerizing ethene using heat and pressure results in LDPE, a branched polymer. So the very branched one is called LDPE. Each molecule contains between 4,000 and 40,000 carbon atoms. So now we talk about copolymers, something new. Copolymers is a polymer formed from 2 or more different types of monomers. Definitions, underline. You must know. So what it means by copolymer means you have more than one type of monomer, they polymerize together. All right, it's not a mixture. It's not a mixture, okay? It still forms a polymer molecule. It's just that the starting monomers, you got more than one variety. Okay, so now you're given ethene, butene, ethene. Confirm will ask you to draw, right? How the copolymer looks. Next, world production, users of polyethylene. Again, definitions, trend, you must underline. You cannot highlight, but you can underline. This sentence is really important. Side chains push the polymer chains away. That means your answer later on must have polymer chain in your answer. How can you use different words? Next, in general, polymer chains with fewer side chains can be arranged closer together. That's why they are more dense, less flexible, stronger, and harder. These are linked. They are linked. So the examiners were very frustrated as well while marking because the examiners didn't know why the students didn't find the answer. The answer is here. What I just highlighted is the answer later on. Okay, so learn to extract information. Whenever there's a definition or trend, underline. That's why if your database is very clean, something is wrong. If you want to get 12 out of 12, you must read carefully. You must annotate. All right. Now, moving on, I'm just going to go very quickly to the answers. Now, part A, I don't think it's very difficult. The similarities are just both are addition polymers made from ethene monomers. They are joined by carbon-carbon single bonds. The second similarity between the LDPE and LLDPE is that they both contain side chains and they are branched. But the differences are in green. LDPE is more branched. LDPE contains side chains with more than one carbon atom, but LLDPE only has methyl side chains. All right, so these are the two differences. But I want to go through part B. Calculate the range of the mass of a single molecule of LDPE. So many of you realize that, oh, I must calculate the number of repeat units. Oh, I must calculate the MR of one repeat unit. So all of you did this. All of you got the 3 ticks there. Good. But you forgot, MR means what? MR is the mass. MR is numerically equals to the mass of 1 mole. They don't want 1 mole. They want 1 molecule. And this is where you got to remember, oh, 1 mole is 6 times 10 to the power of 23. So now I need to take the MR of the polymer, divide by 6 times 10 to the power of 23 in order to find the mass of 1 molecule. So I don't think you will ever forget 6 times 10 to the power of 23 now, given that I've said that 23rd October is Mole Day. Mole Day is celebrated from 6 a.m. to 6 p.m. 6 times 10 to the power of 23. So you have to divide by 6 times 10 to the power of 23 to get an answer. Okay? So I think that's the last step that most of you left out. You forgot to divide by the Avogadro's number, 6 times 10 to the power of 23. Now, the answers for part C are shown here. All right, HDPE is a straight chain polymer, no side chains. Therefore, the polymer chains in HDPE can be packed more closely together. That's why they occupy a smaller volume and hence higher density, because density is mass over volume. So smaller volume, higher density. All right, C part 2. Why does LDPE have a lower roll production? Because it's more branched. It has a lower softening temperature, so it's softer. If it has a lower softening temperature, that means it softens easily. So it's softer, weaker, so it's not very suitable as packaging or building materials. All right. Now, this is where I will stop, okay, for 2022. I hope you realize the importance of close reading. Read carefully what the question wants. All right. If you read carefully, it's quite easy. All right. So I'll just stop here.